The LG Procast is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation.
Welcome to the LG Procast. I'm Terry and Phillip with LG Electronics.
And I'm Philip Craigbaum. We're glad you're here joining us today. Today we're going to unpack VRF. What is VRF? How does it apply to our lives and our industry? And what do we need to know about it? There's a whole lot to discuss, right, Terry?
Yeah, in the world of acronyms, obviously VRF is Variable Refrigerant Flow. And I think it's a wonderful use of words to describe a technology that has really been used in the rest of the world, as we spoke about in our opening episode, really been used in the rest of the world because power is expensive. But I think we'd like to paint a little deeper and broader picture for folks so they get a better understanding of what VRF is, okay?
Yeah, I agree. And the first thing that I wanted to bring up is when I hear VRF, when we're out in the field, we're in the supply houses, somebody says they're working on a VRF job. In our industry, in the United States, we tend to take that and think of commercial jobs. But what about that little bedroom unit or garage unit mini split? Is that a VRF system, Terry?
You know, Philip, that's probably one of the most misused terms when we talk about VRF. You know, if you talk to the commercial sector, exactly what you said. They think it's for, the big jobs, the hospitals, the 10-story, 20-story buildings. But man, I got to tell you, a VRF system is an inverter-driven compressor that's changing hertz, electronic expansion valves, PCBs, right? And then a bunch of logic built into computer chips and stuff, and a bunch of logic that basically drives and changes the hertz of a compressor and allows the correct amount of refrigerant, the variable amount of refrigerant, to be delivered to the indoor units as needed, when needed. It's that simple. And to your point, whether it's a 9,000 BTU 1-to-1 or 50 tons on a roof, it's VRF.
It's all VRF, isn't it?
It is. It truly is.
Yeah. So these guys that are talking about mini splits and these guys that are talking about these big VRF systems, it's the same technology, right?
It is. And, last week we were together. Philip and I got an opportunity to do some stuff down in Dallas together. And I tried to clear it up for our own benefit, for LG's benefit and our internal folks, because we're having to give the same message to them. Right, Philip?
Right. And we can unpack later, maybe either in this episode or later on, what are the differences, because there's not many, between the residential lines and the large commercial series. But let's talk about what the difference is and what a VRF heat pump is. So we talk about heat pumps, right? And you've been in it a long time. I've been in it a little while. And, heat pumps don't work unless you're in the South, or heat pumps are very expensive in the winter because my electric strips have to run. Tell me about some of this, why are today's heat pumps different than the heat pumps of 20 years ago? What's changed?
So the biggest change obviously will be a hertz changing compressor. The ability to change from 10 hertz to 150 hertz on our R1 compressor, which we own a patent for, versus a standard US compressor spinning at 60 hertz. So when you spin at that constant 60 hertz speed, there's physical limitations to ambient temperature, to how cold it can be and still move heat from outside to inside. When you are able to change those hertz and spin that compressor faster, that's lowering the ambient temperature where you're able to go outside and get heat. And so, you think of it this way. If I spin my hands faster and faster, I make more heat, right, between my hands. And that's what that compressor is doing in the simplest of terms. So that single criteria is what's allowed the inverter-driven heat pumps from other markets make their way into the U.S. and dominate what happens in the cold climate and the heat pumper markets.
So we're installing these systems throughout pretty much the entire United States, all 50 states, right?
We are. We actually had a press release about 30 or 40 days ago. I don't know when we'll see this episode, but we had a press release about working with the state of Alaska to install cold climate heat pumps in Alaska. And our CEO, Mr. Yoon, was there. We're on that program. And
right.
So
And I guess, in the back of your mind is, well, I have a gas furnace. So, if my power goes out, I still have heat, right? But I'm pretty sure they require an electric motor to spin that blower wheel, right?
They certainly do. So when the power's out, the power's out. And you get two choices, fireplace or oven, right, for heat. So
Right. Or generator, right?
Or generator, backup power, battery power. So
yeah,
those are the things. But, back to VRF, when you look at how that system operates, and I spent some time today before this podcast just grounding myself and looking at some animated detail and all this crazy nerd stuff to be able to speak. I won't call it intelligently because it is me, but at least talk about heat pump and cold climate and inverter driven. And one of the things that came out of that little session I watched today was just by changing the speed of that compressor, the physics, which we spoke about, the physics allow the refrigerant to boil at different temperatures and do different things and shed heat and absorb heat and be able to go outside and get the heat that is available and bring it inside. And that's pretty cool. And why inverter and why variable refrigerant flow? Because I'm only consuming the power necessary to make the exact amount of BTUs. And that's what hasn't happened in traditional heat pumps, as folks know it.
Yeah. And that's one of the coolest things that I see about it is with a traditional style air conditioner, heat pump, whatever you're working with, or even gas furnace, when that unit is running, you're chasing temperature. In the summer, you're always trying to lower the temperature in the room because you lower it until the thermostat tells you've gone too far. And then you turn off and you wait for it to get too hot again. In the winter, you're blasting heat until it tells you it's too hot in the room, and then it completely shuts off. With an inverter, we get the ability, we can lower the temperature, but we can then turn down the speed of that compressor, close that expansion valve, deliver less refrigerant to the indoor unit or units, and simply maintain the temperature. So we're not fighting temperature all day long, up and down, up and down, up and down. With an inverter, it's get it to where you want it to be, and then it just holds temperature all day long. It's fantastic.
Yeah, we plagiarize the old set it and forget it comments were out there, but that's it in a nutshell, right?
Yeah.
The whole mindset of kick the temperature up when you leave and kick it down and heat, cool, whatever. Man, if you just let this inverter get to temperature and maintain set point, it's just using so much less electricity, and that's a really hard thing for folks to understand. I know, and Philip, that in the inverter world that we work in, our fans run in the cooling mode 24/7 unless you disable it, which we have the capability to do. But then when you talk to folks, they think, oh, that's using so much power, and really it's I did it for an exercise when I was new here. The refrigerator light bulb on a 40-watt refrigerator light bulb, or that little 16-watt light bulb, uses more electricity in a month than my little fan motor did in a month. So, based off the KW rates where I was doing the example. And so they're like, okay, I get it. Okay, it doesn't use any power. So,
yeah, I had this exact conversation about 24 hours ago. I was on the phone with one of my really good friends that lives down in Florida, and he was asking for a couple of pieces of advice. They're putting an addition on his home, and it's going to be two rooms, and so they want 2 units, and the rooms are large enough to sustain independent units. And he goes, yeah, this other room we're not going to use very often, so I'm only just going to turn it on when we're out there. And I said, one, you don't want to do that. You're going to have humidity issues, and it's going to deliver too much refrigerant to the other room, and all the reasons why you probably wouldn't want to, but it's not going to save you anything. These things are so efficient. And I say save you anything. Obviously, our legal is going to jump in there and go, well, you could save $2, but good gracious, they use so little electricity to maintain the temperature in the room. They're so efficient that the benefits of turning them on and turning them off are really not there.
No, I couldn't agree more. We tell folks all the time, like I said before, we set it and forget it, leave it alone, find a number that's good for you on your controller. And if that number is comfortable, Ignore what that number was in the past from your old systems,
Yeah.
just find a number that's good for you. And look, all that happens because VRF, variable refrigerant flow. All that happens because you got a system that's designed to meter and manage the amount of refrigerant that's going to evaporator and evaporators indoor units, as Philip said, because that really separates this technology from what folks are normally accustomed to. And that's the ability to add multiple indoor units to the same outdoor unit and then control spaces accordingly. And I think we're going to talk a little bit more about that on some upcoming episodes, but that's a big separator when you come to why this versus, some other technology that you may be aware of.
Right. And just to restate, I mean, we can do one indoor unit with one outdoor unit, or we can do one outdoor unit with multiple indoor units. And that's really what's cool about this technology is the flexibility is incredible. When you look at a house or a building, hey, design me a system. I get that. Okay, sure. Let me help you. What do you want? And the options are just incredible. The amount of ways that you can rework it. Do we put some ducted units and incorporate some duct work? The mindset that mini splits or wall mounted evaporators are your only option is far from being true. I mean, there's so many different indoor unit options. You've got wall mounted ones that go up high, down low. You've got ceiling cassettes, a couple of different ducted options that are available for you. Heck, we even got a picture frame that hangs on the wall that's your indoor evaporator. I've got one in the box at my home that's going to be installed shortly. And I can't wait to have it up. It's going to be a lot of fun.
Yeah, that's it's if you look at what folks are accustomed to seeing, and if you look at how they've lived their lives with central heating and air, it can be better, right? It can be a lot better. And in my role with LG, with working with builders and developers around the country, that's my messaging. I don't have to, and you don't have to accept things the way they are, right? There's better technology, right? There's better ways to do things, and it's improving on a daily basis, right? So it's the time for folks to just take a breath. You got some incentives out there with the cold climate programs. You got some opportunities. There's a lot of education being built around, a lot of messaging being built around, inverter-driven technology and variable refrigerant flow systems. So it's a good time to be in the HVAC business, and it's a good time for consumers who are looking to use something better in their homes to improve their quality of life and the environment and indoor comfort of their homes. Obviously and clearly, we're spending a bunch more time in our homes because of post-pandemic work styles. So it's becoming more and more relevant to people to make better choices for indoor air comfort and quality.
100%. And you said a word that I think is important that we touch on is incentives, and frankly, it doesn't matter where you fall in the spectrum of political beliefs or what you believe about the global warming or fossil fuels. It does not matter. The reality is that we are moving to an electrified society, and there is incentives being put behind that. The government is putting programs in place that are moving us in this direction. And the only way that we can electrify in cold climates is with inverters. It would make no sense for the state of Massachusetts to mandate all electric units if they were having to rely on resistance heat strips with traditional style heat pumps.
Couldn't say it better. That's what kept the heat pump from already, it's 50-year-old technology. That's what's hindered the heat pump from making it over the southern boundaries or the Mason-Dixon line, whatever you want to call it, right? That's what's prohibited it from going there currently, right? Is the fact that it's expensive to run electric resistance heat, not efficient. It's expensive, right? And so that limited the use of the product, if you will. Variable refrigerant flow changes all that, changes all of it overnight. So
yeah. I've got it in my home. I took out the original system that was in this home. It wasn't the original to the house, but I took it out and put in an LG system with the existing ductwork because it was a still well installed duct system. I did not add any heat strips, and that added 50 amps that sitting in my panel not doing anything. So I just don't need them. And we've been through a couple of really, really cold winters. I say really cold for my area in North Georgia. Getting to single digits is cold for us.
Everywhere.
Yeah, but no heat strips and not a lick of problems. And my power bills are fantastic.
You know, I did the same. I bought a little house, and like all homes, windows, heating, and air conditioning breaks. Well, if you live in the north, they break in the dead of winter, and if you live in the south, they break in the dead of summer. So my wife and I closed on this little home that we live in down here in Florida in March, and in June, the end of June, the HVAC system that was in the house that we bought broke. Right. So if you think getting friends to help you move is hard, call friends and ask them if they climb in an attic with you in Florida in June or July to do air conditioning work, right? All my friends just like vanished, right? So here I am. I'm trying to move this old 1982 central heating and air system out of the attic of this little house and relocate it to the garage and do all the ductwork and everything. Well, it's just my wife and I. And so I'm in the attic with this old air handler, and I'm bringing it to the scuttle hole. And I get it to the scuttle hole, and I'm saying, all right, honey, when I tell you, you push this unit so that it doesn't come falling down on the floor and kill you or something worse, right? She's like, what's worse than killing me? And I go, breaks the concrete on the floor. No, just kidding. But I lost it, right? And all I could do was scream, was like, run. So she ran. And it hit the floor in a million pieces, but it's now out of my attic, and I was able to move it. So, yeah, that's one of those stories you say, man, this is HVAC 101 at its best. So I enjoy every moment of it.
Oh, it always happens that way. Always happens that way. You know, when you need it the most is when it decides that it's time to fail. But yeah, so you put an LG system in your house.
I have.
What was your experience? You live on coastal part of Florida, so you have that stuff called humidity floating around. Did you notice any change?
I do. Of course, with a constant speed system, on at 60 hertz, off at 60 hertz, chasing the temperature. Love that comment. The humidity bounced around because every time it cycled off, the latent load in the house wants to climb, right? And then the fan comes on, tries to recover, and then probably was improperly sized because, like most, the oversize is better, right? Which it's just not. We talked about that, or we'll talk about that. But I manage now, and to your point, I have water on three sides of my house, literally 75 feet to water in three different directions on my house. I manage my house in the summertime to 72 degrees, 48% relative humidity, and I pay a $150 light bill, which includes a boat lift and includes an ice machine running 24/7 and all the laundry that we do. So I couldn't be happier. That 3 months that I lived with that prior U.S. system, my power bill was $275 to $300, no ice machine.
Ooh.
So, and it couldn't manage the temperature below 80 degrees. So that's
a bit of a change.
It made a world of change in here. And look, I've already sold like half a dozen systems around my neighborhood. Why? Because we live in zero lot lines. And these zero lot lines, my equipment, our equipment, as you well know, and the world's learning, it's so quiet. And you just can't hear it running. So when my neighbors are over there like, man, I don't hear your air conditioner, or I hear your neighbor's air conditioner, but I don't hear yours, right? So there's a lot to be said for that. Let me say one more thing about variable refrigerant flow, if I may. So when we went to 410A refrigerant, you remember what happened to the industry, Philip? All outdoor units did what?
Oh, they got big.
They got big, right?
And they're getting bigger.
And they're getting bigger. And then here's VRF, and I got a unit that's a third the size.
But they look funny, Terry. But they look funny, right?
yeah, they don't look like a big square box. They look, they're like a suitcase. But that's a testament to the technology.
Right.
One group is saying, "Oh, the stuff's got to get huge, huge, huge," and the other side says, "No, not really. It doesn't have to. You just need to do some stuff like inverter compressors and expansive valves and the things that we talk about under the VRF side, and all of a sudden you got a smaller system, more efficient system, and it fits right where you want it to fit.
Yeah, yeah. And I was told not too long ago, obviously we all know that refrigerant changes are coming, and we're going to address that in some future episodes. But, some of these units, the 4 and the 5-ton systems, they get a little bit tall. They've got dual fans on them. With the new refrigerants that are coming out, all of our units in the residential world from 9,000 BTUs up to 60,000 BTUs are all going to be single fan units. We're going to be able to shorten them. That's exciting.
Yeah, I was very excited to see that too. There's some code driven stuff out there, like the tall unit in markets like Florida, for example. It has to be fastened to the wall so that it doesn't, for hurricane codes and things like that, and probably some seismic codes out in the California area. But yeah, that's a little top heavy. But I take the top heavy over that big giant 3 times square, noisy square that's sitting on my neighbor's yard versus mine any day.
Yeah. Well, you did conventional heating and air back in the day, as did I. And I know job after job after job, we would go and the new unit wouldn't fit through the fence. It was too big, and whether it was negotiate with the homeowner, hey, when we get here, this section of fence needs to be taken down. Oh yeah, of course, I'll take care of that. You show up at the job, that's never taken down. No. And then you have to do it, which, you're paying your crew to do it. Okay, fine. But then you're liable for if the fence doesn't go back up right. So, how about a unit that is 13 inches or so? It's going to fit through any gate you can find in any home and anywhere.
Put it on 2-wheel dolly, tilt it on its edge, and roll it right through the fence. So, yeah, no problem. So, and again, that's really, really big in these zero lot line communities. Hey, and they're not just zero lot line aren't just where I live, right? They're being built all over our country now because space is such a premium. These builders are building these 2, 3, and 4-story, what they call stack construction things, right? So there's no yards, there's nothing between and it could be in Austin, Texas, or it could be in Iowa or Idaho, where there's plenty of land. It's just they're packing these houses and developments on top of one another. So
yeah, and some of them they have to offset the condensers just so you can walk between the two houses. I mean, they're that indeed. Close, but when you get a unit that can go, we recommend 12 inches from the wall, and there's actually tolerances tighter than that. And then it's only 13 inches thick. You don't run into those issues.
No, you don't. You do not. So variable refrigerant flow, man, the ability to meter and change the amount of refrigerant being delivered to indoor unit or units, right? Smaller pieces of equipment, more efficient pieces of equipment. I just don't know why we wrestle as an industry with the whole technology outside of it's still unknown. But I'm telling you, VRF is the unknown advantage in the HVAC world. That's for sure.
Yeah, all the magic is in those 3 letters, variable refrigerant flow. So we vary the flow of the refrigerant to the indoor unit or units based on the demand. And we do that with the speed of the compressor, and we do it with an electronic expansion valve. So we don't have a TXV. We don't have a thermal expansion valve. We have an electronic expansion valve that's driven by a computer. So yeah, these are, we're moving from the world of mechanical single speed compressors with a mechanical valve and a thermal expansion valve that's metering, or a piston that's metering the amount of refrigerant that goes into a coil. And now we're taking that and we're adding a whole bunch of technology around it. We've got sensors. We know coil temperatures, air temperatures, return air temperatures. And with all of that information that we're gathering, we have the ability to take some computers and some logic and some algorithms, and we can dial it in and be much, much more precise than what we've ever been able to do in the past.
Yeah, man. Welcome to VRF, right? That's what it's about. The U.S. market is awakening to the technology, and it's coming fast. So, congrats, and let's just keep pushing it, right? Spreading the message.
Yeah, it's almost one of those things where it's like finally we're opening our eyes to it, because the majority of the world's been using this technology for decades. This technology was invented in the early 80s over in Japan.
1982 to be exact, right? So it's not like it's smoke and mirrors, and it's not like it's new, right? 1982. So.
Well, Terry, as always, I've enjoyed it. Thanks for being with me. Great time talking about VRF, unpacking what variable refrigerant flow is, what it means in our industry. And I look forward to more episodes where we get to dive a little bit deeper, because that's really what this podcast is all going to be about.
Yeah, you know, Philip, I could talk for days and days about variable refrigerant flow technology, and I just love it. I love what it does for our industry. I love what it does for our electrical grid systems. I love what it does for comfort for people's homes. So, yeah, man, I'm excited about it. And as we move forward in these podcasts, and we begin to uncover more topics, specifically, I think our next episode is going to deal with these top myths in the business or in the industry around this technology. We want to try to dispel some of those. We want to try to bring clarity where there certainly has been no clarity, and we want to make sure that folks understand exactly how we use this product, how we apply this product, and the reasons that it does what it does. So, look for those episodes upcoming. You can find them at LG HVAC, or you can find them on a YouTube channel, or you can find them wherever you're posting your podcast or looking for your podcast stuff as a consumer. So thanks again. See you on the next episode.
Take care. Bye-bye.
See you guys.